Right, so today we're going to look at the distance and midpoint formulas, and we're going to learn how to use them. Yes? Yeah, the stuff we did the other day was the Cartesian plane, and we're going to be doing stuff, the plane and the distance, the midpoint and points and things like that, putting it all together. So, yeah, they go together. And this is all section 1.1, and it's a short section. So I think I was telling... I can't remember who all was here that day. What I think we'll do for this section and probably the next section is put them together in one quiz. Because they're neither one really long, but this unit is long. So we'll double up this time, and we may do that again later another point. But today we're looking at the distance and the midpoint. So have you all worked with the distance formula before? Do you know where it comes from? Anybody know where it comes from? Y'all remember the Pythagorean theorem? Yes, that's it. That's where it came from. Because you can find the length, like if you have... Well, it's not really for that. But if you've got a point here, say what's going on here? Sorry, guys, I'm having some technical difficulties. There's an update for this board, and I haven't let it run. I'm gonna have to do that today. So if you got a point here, and a point here, and a point here, right? Or let's say a point here. Just get rid of that point there. So you can make triangles, right? And then you can figure out the distance between, you can figure out the length of the line segments, and then you can use that information to kind of help you find the distance between 2 points. Okay. So what would be the distance between that point and that point? 3. Okay, 3. It would be, oh, making a mess up here. So we could label that X1, Y1, and this one could be, let's go X2, Y2, and we may not know where they are exactly. But you can take the difference, right? You take the difference between your Y values, and that gives you the length of that line, right? Yes, because it's vertical. So we would have Y3 minus Y1, vice versa, the absolute value of that to give us the length of that line, right? And what about the length of this line? You take the difference of the X values, right? So X3, X2, right? If you have a triangle, you know that the length of that and the length of that, if you square them and add them together, that's going to equal the length, we'll call this side C, right? And so if I take the square root of both sides, then I'm left with the square root, and it doesn't matter if you use x's or y's first. Normally it's written this way. And we use 3 and 2. Then we can find the distance of that line. So ultimately, when we do the distance formula, we clean it up a little bit. We have our x1s and our x2s, and we can figure all that out because we're only looking mainly at the points here, right? And that's the distance formula. Why do the absolute value bars go away?
the square and the absolute value cancel out?
Right, you don't need the absolute value because when you square a difference, whether it's positive or negative, it becomes positive, right? So you can deal with that there. And when you add two positives together, you get back positive. So you can take the square root and then you can find the length. So the absolute value bars are not required. All right, that's kind of where it comes from. I'm not going to ask you to derive it, but that is kind of where it comes from. So what you need to know is the definition of the distance formula. So here's your definition. So the distance between the points, let's say it out loud so you know what I'm writing. And are you all familiar with this notation? Are y'all familiar with that notation? Point A, and it's located at x1, y1. So this is the name of the point, and this is its address in the plane. Okay. And B. And this notation right here, this means the distance between or from A to B. Let's use flannel, I'll say better. What would be another way to say the distance from A to B? What is that? What? Say it'd be a segment because we got endpoints, right? But yes, it'd be the length of that segment, right? So keep that in mind. If you're asked to find the length, you're going to use what formula? The distance formula, right? If you're asked to find the length of a segment between this point and that point, use this. Give me a thumbs up when you're done with that definition. Does it matter whether you write which one is x2 and which one is x1? Like on the points. Just be consistent. So if you use A as your x1, y1, make sure x1 and y1 are in the same place. Try to be consistent. All right, are y'all good? You got it down? You will have access to a calculator for computation only. You will be expected to show all of the work.
So you
need to have it solved. Yeah. You don't have to derive the formula, but you need to know how to use it without a calculator. But I will let you use the calculator to take the square root of some funky numbers to get decimal. Because typically when we're talking about length, I'm not going to say, hey, I live the square root of 16.4372 miles from here, right? That doesn't make any sense, right? So I will let you use calculators for stuff like that, but I'm going to try to make sure that you have problems where you may not really need a calculator. So, because I don't have a class set of calculators. Yes. Yes.
I don't really get where like the x1 and x2 are. Like where does the 1 and the 2?
Those are just indicators to say, hey, this x1 belongs with that point. They're identifiers. It's like it's that x, not that x.
So it's just so you can tell the difference between the two x's?
Yeah, yep, that's all it is. Because this is the x that belongs to point A, and that's the x that belongs to point B. And the y's are the same. Yes?
So if you start looking at the
Yeah. Likely, it's not always, but likely, yeah. X2 and X1 are generally not the same, but they could be the same. When would they be the same? When would your X values be the same? That's on a vertical line, right? Yeah. So
Oh, so the X's and Y are talking about like
the coordinates of the points. Yep. That's where they come from. Good questions. Any others? Any other questions? Those are good questions. Okay. You ready to start using it? Did y'all get all this down on your paper? You got the formula? All right. All right, so let's look. So sometimes you'll have a question that will say, find the distance between the points A at 2,5 and B at 4 negative. All right, so that's what the questions will look like. This is an example. So where do I start?
is that a comma?
Between the 4 and the negative 1? This is just a scratch that my sleeve made. Is that, yeah, you start plugging them in. Identify your part. So we call it X1, Y1, X2, Y2. We know that the distance between A and B is equal to the square root of X2 minus X1, so 4 minus 2 squared, plus Y2 minus Y1 squared, right? So now let's whittle that down just a little bit further. So we still are dealing with the distance between A and B. What is 4 minus 2? And then that's going to be squared. And what about negative 1 minus 5? Negative 6. And notice it's in parentheses. That means the negative and the 6 are both squared. What's 2 squared? 4. And negative 6 times negative 6? 36. So that's equal to the square root of 40, which is approximately 6.32. Use approximation symbols when you approximate your radical if it is not exact. When could I use exact equal signs? If they're perfect squares, right? Yep. Otherwise, that's not actually equal. That's an approximation. Because that decimal probably goes on for a lot longer than that. Okay?
The square root of 40.
Yep.
Why would the square root not cancel out with the numbers being squared?
That's not how it works. Remember, I'm glad you brought that up. Here is common error number 532. The square root of a squared plus b squared does not necessarily equal the square root of a squared plus the square root of b squared. Okay? Let's let a equal 3 and b equal 2. So that's the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13, right? Now this, if we let a equal 3, we get the square root of 9 plus the square root of 4, which is equal to 3 plus 2, which is equal to 5, and those are clearly not equal to each other, right?
I think I'm kind of confused because I was thinking of it being squared on the outside of the square root, which
That's what
would
I'm-
cancel out.
Right, if it was outside of it, yes, that's different.
But okay, yeah, that's
If it's
right.
underneath that radical, it's pinned in there until you can get down with it, yeah.
So if the squared is on not the numbers, like it's outside the radical, then the square and the radical cancels out.
Yes, but if it's underneath that radical
That's what
sign,
I was getting.
yeah. But that's a really common error. That's a very common error. Yep. So let me change colors here and put that in a special box. So avoid that. There you're doing these. Okay, avoid that common error. Now, if we were multiplying underneath there, we have some different things going on. The radical does break apart, remember, under products, but with terms, it's a little bit different. All right, are y'all okay with that? Sort of? Want to do another one?
So we just plug it in.
All right, so let's do another one. Can I move to the next slide? Y'all got all this that you want? Okay. I get you for 45 to 50 minutes, and you get all of me for 45 to 50 minutes. Okay. All right. So let's look at the next one. Okay. You may see a question that looks like this. So you need to know what to do in this situation. Here's another example. Which point P well, it's negative 1 or 2. Sorry, switch the signs of those. Or Q. They tend to like to use A and B and P and Q a lot for points. You'll see that. Is closer to the point R. 5, 3. So here's the question. Which point is closer to that point R? How are you going to find out? Check the distance between P and R and the distance between Q and R, right? Which one's going to be the closest? The one with the smallest distance, right? So let's go through that. So let's start with P and R. So the distance from point P to point R, I don't know what's wrong with my hands today. I'm not writing very well. I do apologize. Is equal to the square root of, what is the x value of P? 1. And the x value of R? Squared plus the y value of P. And the y value of R. Whoops. Squared. Okay. Do you agree?
So, like, it doesn't matter if you put P or R first.
No. You'll find that once you square them, it's going to come out the same either way.
Question.
Yes.
Say that like say that was -3 instead of 3. When I plug it in, would it be -3? Or
Yeah, it'd
minus
be-
3 or plus.
It'd be minus -3, which is plus 3.
Okay.
Yes.
Because I wrote 5 minus 1 and then 3 plus 2.
Perfect. You're going to get the same answer as me. You work yours out, I'll work mine out. The unit is long, but the sections are not long. That makes sense?
It's just
It probably won't take as long to get to it. My last group, the whole first 9 weeks was a prerequisite, and we only covered 3 sections, but we were able to get through the rest of the project. the prerequisites are harder, I feel like, because it's so meticulous and detailed in that one thing. Like, you know everything about that one thing, right? This is stuff that you all have been doing for a long time, right? I mean, already we're basically done with this section today. We'll finish this section today. We're working on it for 2 days. So we'll pick up another section probably on Friday. Tomorrow. All right. So 1 minus 5 squared is -4 squared, right? And -2 minus 3 is -5 squared. So you get the square root of 16 plus 25, which is equal to the square root of 41. Is that true? Right? Is that what you got? Is that what you got? Yeah. So Sydney had hers flipped, and we both got the same answer. So it works the same way. All right, I'm going to leave it that way for just a minute because I'm just trying to see which one is shorter or longer, and I'll be able to do that without actually knowing its approximate value. And so now let's look at the distance. I'm going to do this in a different color. So now let's look at the distance between Q and R. So again, that's going to be the x value of Q minus the x value of R squared plus the x value or the y value of Q minus the y value of R squared. And as we follow through, square root 3 squared plus 6 squared equals square root of 9 plus 36, which equals the square root of 45. So which one is closer? P, right. So we would just say P is closer to R. Yes? Good. I'll put this on with the thing today. All right, any questions so far on that? Okay. All right, that's basically the distance formula in a nutshell. The next thing that we're going to look at is the midpoint. So sometimes you're going to be asked to find the midpoint of a segment, or you're going to ask to find whether or not something bisects another segment. What does it mean to bisect something? What? Splits it in two what? Equal parts. Yeah, 2 halves. I mean, if it cuts it like, and you got a line that's on one side and cuts up here, it doesn't bisect it. But if it cuts it through the middle, through the midpoint, the center, it is bisected. So you may have a question where it'll ask if something bisects another one, the segment bisects a different part. You'll see that on your homework. I think that I put that on. All right. Can we slide to the next slide? Slide to the next slide. You can tell it's Thursday. My vocabulary is starting to wane. Just get it out. All right, let's look at the midpoint formula. And let's reason through this real quick. Now, the result of the midpoint formula is not going to be a distance, right? It's going to be an actual point that's in the middle of a segment. So if I've got a line segment, let's say I've got, say this is my graph, right? And I've got a segment here. How am I going to figure out where the midpoint is? Well, we're going to divide something by 2, right? The distance by 2. But we're looking for the point, right? So to find the value of the midpoint, let's see, is that approximately the midpoint, we'll say? That's going to be the sum of the y's and the sum of the x's, both of those divided by 2. So this is going to be x1 plus x2 over 2. Whoops. Comma, y1 plus y2 over 2. All right, so the midpoint is actually a point, right? It's not a distance, it's a point. And so to find it, that's your formula. Yep. That's the midpoint. And so if you take, and I'm going to use different colors, and you go from here, let's see, there, you come on down. If you divide that in half, so like here you get a triangle, right? And then if you go from here down to here, you get another triangle. So let me fix that. Okay. So you got 2 triangles, and then here you see the distances between the x's, divide that by 2, and the differences of the y's, divide that by 2. All right, so let's use that. Let me give you the proper definition. Can I go to the next slide? Yes. I think I still got one more running. Let me just write here. This is your definition. The midpoint of a segment from A to B That's all it is. X1, Y1. There's a comma in between. Yeah.
Those Z's on who?
Twos. My Z's usually have lines between them. But it can be either way that you want.
What are the little lines?
The 2 hash marks, that shows that they're the same. They're congruent. All right, can I go to the next slide now? So we can practice this before I let you lose on your homework. We good? All right. So let's look at one. You may have a question that says something along the lines of find the midpoint of the segment that joins point A at actually, it doesn't name it. Let's not name it. Joins. -2, 1. And okay. So find the midpoint of the line segment that joins those two things together. So what will we do? Okay, so -2 plus 4/2. And since we use this x as our first x, we'll use this as our first y. But we're adding, so it's not such a big deal.
Did you just put a comma between?
Yep, because it's a point, right? Midpoint is actually the coordinates of a point. All right, good question. So where do I go from here?
At the top.
Yep. Carry out the addition on the numerators. -2 plus 4 is 2/2, which we're going to change. And 1 plus 5 is 6/2. And let's simplify. So that equals what? 1, 3. So that's where the midpoint of that segment is. Yes? Yes. All right. We okay? Good. And finally, the application of the midpoint formula. So you may have a question that says, show that the quadrilateral with certain vertices is a parallelogram by proving that its two diagonals bisect each other. Okay? So, what are you going to have to do to find that out? You'll find the midpoint of each one, right? And if it's the same place, then that's right. That's it. All right. Are we done with this one? So, show that the quadrilateral with vertices, you all know that vertices are points, right? They're edges, like endpoints. Is a parallelogram. By proving that its diagonals bisect. And sometimes it's best to draw a picture so you can kind of see what's happening. So I'm going to kind of sketch this out a little bit. So I've got a point at So I got a point at 1, 2, right? So 1, 2. Got a point at 4, 4. Got a point at 5, 9. and a point at 2, 7. So I've got this parallelogram that's kind of like this, right? And I've got my point P right here. I've got my point Q right here, R and S, right? So what I need to know then is the diagonals are going to be here and here, right? Like a kite. So what I need to know then is the distance from P to R. Well, not the distance, the midpoint. Sorry. I need to know the midpoint from P to R. And I need to know the midpoint for QS. I'm going to put it in mid here. And midpoint. Let me fix that since it's sloppy. So what's the midpoint of PR? Charlie? So these two diagonals, there and there, we want to make sure that they bisect each other. So this would be one line, right? Let me change colors here. So we want to know this line and the yellow line. We want to know if these are equal and those are equal, right? If they bisect each other. They don't have to be equal to each other, but their midpoints will have to be in the same place if they're bisecting each other. That's the diagonal of those shapes. Yeah. That's what they're called. Yeah. Yeah. In geometry, that's what they're geometric. Okay. So what is the midpoint then of PR? Wait, what did I put? QS? Yeah. Midpoint of PR. How do we find it? Okay. 1 plus 5 over 2 and 2 plus 9 over 2. So what does that give me? 6 over 2, comma 11 over 2. And then that eventually simplifies down to 3, comma 11 halves, right? What about QS?
4 plus 2.
4 plus 2 over 2. Good. And
4 plus 7 over 2.
And that turns into 4 plus 2 is 6 over 2. And 11 over 2 again. Are they the same? They are the same. So they, since they're the same, the diagonals bisect each other. And therefore, because of a theorem in geometry, that means that those are, that is a parallelogram. Okay. Okay. That's all I really have for you today. Do you want to see? I gave you your homework set, so I'm going to give you the next. You have about 10 minutes. The bell has started ringing a little bit later than usual. I can't remember what it rang at yesterday. But you've got a few minutes. Go ahead and start looking at the homework that I gave you. The first part is basically graphing points, identifying where points are located on the graph. and things like that. And then the second part is more this type of stuff. And it goes into some applications at the very end. And we will do a writing piece probably in here over completing a line segment or a parallelogram. You'll have a choice, whichever one you want. Okay. That'll be your first portfolio piece to put in your Google site.
Would you consider?
I put it.
Okay, I need to see, I don't know. But it's not, okay, put it. On the first page of the. Yes, 123.
Is Tuesday an encouraging?
Yeah, good question. I've answered it a couple different times, but let's go ahead and remind ourselves. If it's on an axis, is it in a quadrant? No, it's just on the axis. So don't include those like in one of the quadrants. They're on the axis, not in a quadrant. Kind of like when you stand on the state line or you're in Kentucky or Tennessee. On the line. Depends on how you stand on them, yes.
So, quadrant three should be new.
Yeah.